Today we're going to pick up kind of where we were last time, except I was able to get the application to run. And I was able to get the application to run after doing a bunch of stuff. All right? This is one of the reasons why I recommend you do it on the laptop, because the machines on campus, if you were to pull down a sample application from somewhere, if it was compiled with if it was created with a different target, if you don't have that target, you have to download it and blah, 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 blah. I had to, and the machines reset every day, right? All right, actually every time they reboot. So that's why I suggest that if you have a laptop, you install Android Studio on it and work on it. If not, I can work with you and I can maybe have them change the machine so that it can retain what we need for it to run. So there's actually a couple of things. There's the SDK framework and there are build tools, and both of them have to be set to the right thing for it to work. So I finally got all that. In the middle of this, in the middle of installing about 3 or 4 more things, and it's pretty straightforward. You don't really need to know much. It pops up and says, this is not available. Click this to install. You click that, it installs. The problem is waiting for it to install, right? But other than that, I mean, it's not like hard. I did run into one problem I had to research, and I posted an announcement concerning that. So we'll take a look at that if you run into it. In general, you know, if you get an error message, Google the error message, and usually you're pointed in the right direction. So let me bring up this application, and we'll start looking at it. Before we do that, though, I want to talk about resource qualifiers, and I want to talk about density-independent pixels. All right? A little bit confusing. Density-independent pixels, but once you get the hang of it, it's a piece of cake. So, I want to talk about this because I think, as I was explaining it last time, how do I want to put this? As I was explaining it last time, it seemed to me like I didn't want to just jump in and look at it, that I wanted to sort of give an introduction to resource and resource qualifiers before we go into this material heavy. And my screen has a blue tint. I hope the projector projects it correctly. Let me start by Googling Android resource qualifiers. Actually, my background is blue, so that might be what's going on. I forgot I set my background to blue. It's going to be one of those semesters, I think. here a list of the resources that we provide. And these resources are all XML files. All right? Mostly XML files. They can also include images, image files, audio files, things like that. In the Java, you're going to have your code. Under resources, you might have drawables. And drawables are images that you might use, so there might be a graphic. There might be a layout, which is going to be the actual screen layout, expressed in an XML file that contains a number of views. MIP map, which are like your icons. And your values, which we talked about before. The values is where your string values and other values go. So remember, we're not going to hard code any strings for any labels for anything in our application. We're going to put them in this resource file, and we're going to refer to them as being in the resource file. And we said that that's for a number of reasons. That's for maintainability, which most good programming practices are for. All right? It's also for consistency. If you had a contact email address that appeared many times within your application, rather than having that hard-coded on several of your screens, you would create a string value for it, and you would point to that string value. So if your contact email changed, you just need to change it in the string file. So all those are good reasons for the resource for strings. Now, we can add on to this resource qualifiers. These folders, as you see written here, are the defaults. There's no qualifier. How can I tell at a glance that there's no qualifier? The qualifiers are a dash and then something else after the name of the folder. So if you see values dash something, that means that it's a resource qualifier for values. If you see layout dash something, that's a resource qualifier. What does a resource qualifier mean? It's a conditional thing. If a certain condition is met, the Android operating system will use that resource file instead of the default resource file. So these are the default resources. The default resources will be in layout and MIP map and values and so on. However, you can say under certain conditions, don't use those files, use these files. So what are some of those conditions that you can describe? Well, one of them we talked about last time is language. All right, and that's one of our examples shown here. Here's a list of all the resource folders that exist in addition to the ones we covered for animations, different kinds of animations, for colors, for drawables, for icons, layout, menus, files stored in a raw format, values, and so on. Alternative resources are different than the default, when you want to apply different than the default. And what are some examples of that? Well, one of them is your drawable folder. You might have a different file of things. You might have different files, different graphic files, if it is high density pixels per inch. All right. So for devices with a high density screen, it would use these files. All right. Would those files likely be bigger or smaller than the default? Bigger, right? You have a high density. If I use the same file on a high density screen, all right, how would it compare with a low density screen? So I have two devices, let's say. One is normal density, one's high density. And I display the exact same file in both of them. How will the file look on the high density screen? Bigger or smaller than on the lower density machine? It'll look smaller. All right? Because there's more dots per inch. All right? So if you have a let's say you have something, a medium density device that might be 160 pixels per inch. And if you had a pixel that, or if you had an image that was 320 pixels wide, that would take up 2 inches on a 160 pixel per inch monitor or device screen. All right, that would be maybe a medium density. On a high density, maybe it would be 320 pixels per inch, which means that that 320 pixel image, let's say it was a square, would be an inch by an inch. So if you don't supply alternatives, then the images on your high density device are going to be tiny. They're going to be small. So you would provide bigger images because you could take up, you could put a same image, or you could put a larger image and it will take up the same amount of space on a high density than a smaller image would and on a low density. We'll talk about pixels and density independent pixels in a minute here, but that's one of the things that you can do alternative resources for. So a higher density machine, you probably will have a bigger icon. You'll probably have bigger versions of your images. Here's some other possibilities. Language and region. All right? You can put -en after it. You can put FR after it, which would mean it was French. Now, and again, I only had 2 years of high school English, or of high school French, but I assume there's a difference between Canadian French and France French. All right? So not only will you specify that it's French, you can specify regionally if it's France French or Canadian French. Or English in the United States versus English in the United Kingdom. You could put a region on there if you wanted to make different. In the British, the UK version, you put extra U's in words. It's near as all I know. All right. Layout direction. All right. The smallest width of the screen. The shortest dimension of the screen. Available width. Available height. Screen size. Is it a small screen, a normal screen, a large screen, or an extra large screen? And it describes what those things mean. 320 by 426 dp would be a small screen. This would be a larger screen. This would be the largest screen. Are they long screens? That is the aspect ratio. Are they longer than the normal sort of screens? There's a whole bunch of these. I'm not going to go through all of them. But I do want to go over this one. A screen pixel density. A low density screen is considered to be 120 pixels per inch. Medium density is considered to be 160 pixels per inch. High density is considered to be 240 density pixels per inch. Extra HD is approximately 320, and so on. So remember how we use these. When we create these resource files, we will put after the name of the file dash something. We might want to have a different layout file for the United States versus another country, in which case we could have, or an English versus a French, or whatever. And we would qualify the resource by putting a dash and the language that we wanted it for, a dash and the density we wanted it for. The nice thing is the framework handles this on its own. We don't have to write any code like to say, well, if it's English, use this file. The framework is smart enough to know which resource to use based on the characteristics of the device that we are viewing our app on. All right? We're gonna see a few examples of these. The examples we're going to see right off the bat are going to be for languages and for the screen density. Those are kind of the most obvious ones. And then we might get into other ones as the semester progresses. An obvious case of this is if you had an application on a small screen versus a big screen, you have more real estate on a big screen, right? So maybe your screen is configured differently. Just like the difference between a screen, a giant monitor screen and a smaller laptop screen. You might want to have your screen, your UI, configured differently for those two situations. You have more real estate on a larger screen, so you could maybe put things side by side. Where on a very small screen, side by side usually isn't a good idea. So you might have a different UI for a tablet-sized device than you would for a phone-sized device. All that's accomplished via these resource qualifiers. Like I said, the ones we're going to examine first are high density, or the density of the device, the pixels per inch, and languages. All right. Density-independent pixels. Let's see if I can find a good resource right off the bat. Now, here's one thing that was a little bit hard for me to understand at first. All right? But when it clicked, it really made sense. Screen density is not the same as screen size. All right? These two devices, hypothetically, could have the same screen size physically, but there might be more pixels packed into them. So the one on the right has a greater screen density. Therefore, you can see the image with an A in it looks a little bit sharper, whereas this one is very much pixelated. You could see the jagged edges and so on.
You mentioned in your web development classes too, for like using like pixel measurements too when doing the layout.
Right. So what we're going to use in this class is we're going to use density-independent pixels. So, for example, we say here that we have this text view that's going to be, or we have this button with a margin or a text view with a pixel size or whatever. We either use DP or we can also use SP. SP is a lot like DP, except it's for fonts rather than for images. The way it works is like this. The actual size that's going to be displayed depends on the screen density. All right? Sort of the benchmark for screen density is what they consider a medium density thing, or 160 pixels per inch. That's considered sort of the baseline. So, let's say we have an image, or we want to make a text box or anything, but let's say we have an image. And let's say the image is, well, let's talk about a text box instead. 20 pixels. All right? It's kind of a small text box. Let's say 200, let's say 120, 160 pixels wide. All right? Now, if we said we wanted 160 pixels wide, if we had 3 devices with different screen densities, could be the same size device, mind you, but if we had 3 devices with different screen densities, it would be different sizes. So if we had 120 pixel per inch, screen, 160 pixel per inch, 240 pixels per inch, and 320 pixels per inch. I didn't pick these numbers out of my head. This relates to low density, medium density, high density, and extra high density. If I said I want this to be 160 pixels wide, how big would it be if there's 120 pixels per inch? How many inches would it be? It would be 1¼ right? Yeah. All right. This is my Friday. All right. So, yeah, it would be 1¼ inch long. So, pardon me?
That's more than half my screen width.
Well, yeah, exactly. So 1¼ inch. 160 pixels per inch. This one I can even do now, even though it's my Friday and it's the first week and I'm tired. How big would this be? An inch, right? There's 160 pixels and 160 pixels per inch. This would be an inch wide. 240 pixels, how big would it be?
Half an inch.
3/4 of an inch.
I was thinking 120, sorry.
And on 320, I think I can get this one too. Be a ½ inch big. All right, these probably aren't drawn to scale, but you get the idea. All right. If I were to display, if I stated that I wanted this text box to be 160 pixels wide, it would go all the way from 1¼ inch on a low density device to a ½ inch on an extra high density device. Well, that's probably not good, right? What we would like to say is we'd like to express this in a way where it's going to adjust the size based on the density of the screen. So it'll make them all physically approximately the same size. I say approximately because, you know, it might not be exactly 320 the density of a high definition or high density. All right. So I would use 160 DIP or 160 DP. That means density independent pixels. Or if I'm using something that's going to contain characters, I could say SP. These are roughly, for our purposes, they're roughly the same thing. All right? And what it's going to do is it's going to scale it differently on the different devices. So, the baseline is the median density of 160 pixels per inch. So if I said I wanted this to be 160 dp wide, it's going to make it an inch. Because to calculate the pixels, you take the density independent pixels, all right, times the device's density over 160. So I take this number, how big I want it to be, times the density of the device over 160. So in this case, I take 160 divided by 120 over 160. So that would be 3/4 of 160, right? Which would be, lo and behold, because I cleverly picked 160, it's going to be 120 pixels, or 1 inch. On this side, it's going to be 160 pixels, or 1 inch. On this one, it's going to be 240 pixels, or 1 inch. On this one, it's going to be 320 pixels, or 1 inch. So by using density-independent pixels, or SPs, they will physically be the same size because the size will be adjusted for the density of the screen. All right? That applies whether we're talking about icons or text boxes or images or anything we do. So we're going to be giving things a density-independent pixels. We're going to figure out approximately how big we want something to be on a 160 pixels per inch device, and that's how many dp it's going to be. And then that will automatically be adjusted if we have a high density or a low density device. All right. So, what did we cover from last time? We looked at resources. We looked at resource qualifiers. We looked at density-independent pixels. Now, to bring everything together, I want to run that app that we looked at last time, that we tried to look at, and we can look at it and we can examine the resources in a little more detail, and we can probably come to some conclusions.
What was the DP variable? Was that the goal? We wanted it in 160?
The DP is the density-independent pixels. That would be how many pixels it would be on a medium density device.
I got about 3/4 of that. So
Okay.
What was the output result? Was the pixels?
The output result, I mean, it displays in pixels on your screen.
Okay.
And it takes the density-independent pixels and figures out, based on the density of the device, how big to physically make it. So it translates the density-independent pixels into actual pixels.
Okay, and this is on the fly.
And it does that on the fly.
Okay.
Yep. Okay. So I have Android Studio. Let me go and open. My welcome application. And again, after tweaking and installing a bunch of stuff and so on, I came up with a version that compiles cleanly. All right. One thing that I ran into is described in this announcement. I ran into a problem importing the welcome app. This page describes a solution. So if you want to see what that is, go to that. And I simply followed these instructions and it cleared up the problem just like it said it would. Okay, let's go and run this. Now to run this, notice I don't have an Android device connected to this computer. So it's going to create an emulator. All right, it's going to create a virtual device using an emulator. Well, as you might imagine, I can emulate a bunch of stuff. So I can create a bunch of virtual devices. And that would be a good idea, right? Because if I was testing, let's say, a very robust application, something that I wanted to look different for different size screens and different densities of screens and different languages, I might create a whole bunch of virtual devices. Okay? I've just, to get this running, I created one. When you create a virtual device, you have to download sort of God, the name's escaping me. We'll see when I look at the virtual device. I'll click New to see the word, because again, I'm forgetting the word. So I click Run. It's looking for the virtual devices. This is the one I created the other day. If I wanted to create a new one, I'd click Create, and I'd pick exactly what kind I wanted. So I could pick a Nexus 1 that's that size, a Nexus 6P that's that size, a Galaxy Nexus, a tiny old phone, all right, a TV, something wearable, or a tablet. I could pick any of those. You can also download a hardware, let's see, new hardware profile. Okay, you can actually sort of make your own based on different characteristics. And the size of it, and the resolution, and so on. Here we go. System image. That's the word I couldn't think of. You have to define a system image. In other words, what the system looks like. And it recommends the ones for faster performance. So they recommend these images because they run fastest and support the Google API. So I think I picked API of 28. All right, the bottom line is I created that profile before. If you haven't already created a profile, you need to create one. All right? And again, as we're testing more and more things, we probably will want to test with multiple virtual devices because we might want to test for different sizes, different densities, and so on. So I'll click OK, and up will come a virtual Android device. Doesn't take terribly long to do this, at least on a machine that has decent performance. The problem it's running into is I already installed it, so it's getting confused and angry, so I'm going to say yes, I want to uninstall it. Try again. Let me create a new virtual device. Well, it's a good example of troubleshooting. Let's see. Let's go in and say, let's build, let's,
Maybe need a lower version of the API or something.
it's possible, but there we go. I just went clean and rebuilt it, and it seemed to take care of it. And finally, there's our application. All right. Notice a few things. Welcome. Welcome to Android application. And the Deitel bug. I don't know, that's a symbol of the publisher of this. All right. That does that. Really, all I did to rerun it is I just went through build and went clean and clicked build again, and again it cleared out whatever problems. I did move this stuff around because I did have it on my desktop and I moved it, so it's possible that that was, it didn't like what I did with that. All right, let's go and visit this. Now I had a little bit of a late start today, so I'll go a little bit long after the time because we should be done by now, but I'll go a few minutes over to sort of make up for that. All right. There's the code. Here are the resources, Java and resources. Under drawable, we have the bug image, all right, which is that image. Let's look at the layout to see how that bug is created. So it is a big old bug, all right. It is 1,000 pixels wide, 1180, and 602 pixels. And this virtual machine is not, this virtual device is probably not 1,000 pixels wide. All right. I forgot to look when I created it, but it's probably substantially smaller than that. Let's look at what the layout says. The layout says that the image is, well, that's a text. Well, the image view doesn't have any kind of size to it. It says wrap content. Wrap content means it will make the image as big as it'll make the image as big as it needs to be to put it on.
It doesn't have a height.
It has a height of 0 dp, and I'm not really sure why it did that.
I think it's mostly just so it's.
I think that will calculate the height. I think you need to give it a height and a width. Giving it 0 dp means it will calculate the height. Okay. So that gets filled in the image view. All right. Notice how we refer to that. We say ID bug image view. Now notice in this, oh, that's the ID for the image view. the image itself is in the drawable resources, and it's called bug. All right? I got confused for a second, this ID. The ID is the ID of the image view. That is if we wanted to programmatically change the image. So that maybe if you clicked on the image, the bug went from a regular bug to a smashed bug. All right, we could code something that did that. The drawable, though, is from the drawable section, and it's called bug. So that's what puts that bug in that image. It's going to be as big as it needs to be. That's what wrap content means. All right? The text. This is actually bad because the text has a hard-coded string in it. You should not do that. All right? We should instead be referring to a string variable that exists here. Should actually refer to that welcome word. So that should say @string welcome. Again, makes it wrap content so as big as it needs to be. The layout is defined as linear, which means it's going to stack these on top of each other. Because it's defined as linear and the orientation is defined as vertical. If we made this horizontal, let's see what happens. Actually, it doesn't display it right. We must have confused it with that. We'll change it back to vertical. Because it said both of them, the width is, well, let's do this. Let's make the width 100 dp, layout width, layout height 10 dp. Still doesn't work. Let's set this back. Let's click undo a few times. Actually, notice what it said. When that said horizontal, it gave me an error message. This will make the view invisible, because with the horizontal and making it 0 height, it doesn't work. My guess would be is I would have to set the height and let it automatically calculate the width or something. I don't feel like playing around with that.
So can you have like two separate linear layouts, one for vertical and the other for horizontal?
Yes, that would be a resource qualifier. Okay, because as this is now, if I go and rotate this phone, let's go back here and rerun it. I rotate it, right now it has the same layout. So if I rotate the phone, it doesn't do anything. It just rotates it and leaves it like that. We could actually write another layout with a resource qualifier saying when the orientation is landscape, use this. All right, let's spend a minute to look at the code. Here we see, again, we define colors, and then in our activity main, we refer to those colors for different things on the screen. Where would be an example of that? And likewise, we do that with dimension and so on. Here, we make the text color. We don't give it a hard-coded color. We say the text color is @color, welcome text color. That way we can keep things consistent. If we want the same text color throughout our app, we could define the color of all our text things to be text color. All right? Our code here does almost absolutely nothing, but one thing. It just pops up the screen. Right? We have our activity. We have an onCreate method within that activity, and we simply say, we call the super function, that is the ancestor, the superclass's onCreate function to handle the initialization that exists in the framework, because we're overriding that function here on our subclass. Our activity inherits from app_compat activity, and there's a bunch of initialization that happens within the Android framework. All right, we still want that to happen, but we want to do our own thing. So first we call the super classes initialization. Then we call setContentView, and we set the content view, that is the screen that the user is going to see, to our layout activity main, which is this XML file. Notice that you can view the XML file either in text mode or design mode. I generally prefer to work in text mode, but you could also look and work in design mode if you want to. That gives you a more graphical picture of things. The reason I don't like this is it does things in a very brute force way, and as such, it doesn't necessarily do the best coding. Again, it's like with any GUI. When you drag and drop stuff, it does it sort of in a very mechanical, brute force way, and it's better to, if you can, it's better to code it where you have complete control over that. All right. Are there any questions about this? My suggestion is, if you could do this, actually I asked you to do this with the tip calculator. So you can download the tip calculator. We'll look at the tip calculator next week, and we'll look at sort of two things, two versions of the tip calculator. The one that's in the Deitel downloads, and then sort of a simplified version that I created that just demonstrates a few things. Because the next thing we want to do is we want to do interactivity, like what happens when someone clicks a button so that we can do some math, or someone enters a value into a text field, or someone drags a slider or something like that. And that's what we'll look at on Tuesday of next week. Any questions? All right, we will see you. Is anyone going to lab? Okay. All right. So those that go to lab, we'll see you in lab. Otherwise, we'll see you next week.